Hello and welcome to Mr. Alvarez's virtual chemistry classroom. Today we'll be learning about density. Our aim for today is how can we calculate the density of an object? First, let's start off with a thinking question. Which do you think would have a greater mass and why? 1 kilogram of feathers or 1 kilogram of rock? I'll pause here for you to think about this. So what do you think? Which will have a greater mass? 1 kilogram of feathers or 1 kilogram of rock? And why? Well, if you said 1 kilogram of feathers, you would be incorrect. But if you said 1 kilogram of rock, you would also be incorrect. The reason is you have 1 kilogram of each substance. So if you have 1 kilogram of feathers, that's going to have the same mass as 1 kilogram of rock. But what's the difference? Well, since feathers are generally more lighter than rock, if you have the same mass of each, the feather is going to take up much more room. The 1 kilogram of feathers is going to have a greater volume. The reason for that has to do with density. Rocks are more dense than feathers. Therefore, if you have the same mass of rocks as you do of feathers, the feathers are going to take up more volume. So how do mass, volume, and density relate? Well, mass is the amount of matter an object has, and that's going to be measured in grams. Volume is the amount of space an object takes up, and that will be measured in either milliliters or cubic centimeters, cm to the third power. Density is a measurement of how much matter is contained in a certain volume of a substance. And that will be measured in either grams per milliliter or grams per cubic centimeter. In our previous example, we had the rocks and the feathers. They both had a mass of 1 kilogram. But since the rocks were more dense than the feathers, that 1 kilogram of mass took up less space or less volume than the feathers. Greater density for the rocks, same mass, but took up less space. The feathers, which are less dense, took up more space than the rocks. Once again, since the rocks and feathers had the same mass, 1 kilogram, the feathers, which were less dense, took up more space, and the rocks, which were more dense, took up less space. Before we calculate the density of an object, we need to find the mass and volume of that object. Now, finding the mass of an object is usually pretty simple. All we have to do is take that object and place it on either a triple beam balance or an electronic scale. Sometimes, if we have an irregularly shaped object, it's a little bit more difficult to find the volume, but there is a way around that. First, we'll take a graduated cylinder and fill it up with a known amount of water. For example, 50 milliliters. Then we could take that object and drop it into the graduated cylinder and record the new volume. To find the volume of just the object, we would subtract the new volume from the original volume, in this case 50 milliliters, and the difference would be the volume of that object. Let's take a look at an example. In this example, we want to find the volume of this marble, which has an irregular shape. So what we do is we take this graduated cylinder and we filled it up with 20 milliliters of water. Then we drop the marble carefully into the graduated cylinder, and the water level rises to 25 milliliters. The new volume of the graduated cylinder is 25 milliliters. The original volume of the graduated cylinder is 20 milliliters. So what we do is subtract the water, the volume of the water plus the marble, minus the volume of just the water. So water plus marble minus the volume of just the water. And if we subtract 25 milliliters minus 20 milliliters, we find out the marble has a volume of 5 milliliters. And that brings us to the density formula. The formula for density is density equals mass divided by volume. Or, to write it simpler, D equals M over V. Let's do some practice problems together. Practice problem number 1 states, a block of aluminum occupies a volume of 15.0 milliliters and has a mass of 40.5 grams. What is its density? The first thing we do is we write our formula. D equals M over V. The second thing we do is we write our known and unknown values. D equals, well, that's what we're trying to find. So we're going to put a question mark there. Mass, the aluminum has a mass of 40.5 grams. And the volume, there's a volume of 15.0 milliliters. From there, we plug our knowns and unknowns into the equation. So D equals, the mass is 40.5 grams, divided by the volume, 15.0 milliliters. And if we were to divide those two numbers, 40.5 divided by 15, that would give us 2.7, and our unit would be grams per milliliter. Now, anytime we solve a problem, we have to make sure it has the appropriate number of significant figures. We go back to our original numbers. 40.5 has 3 significant figures. 15.0 has 3 significant figures. Our answer only has 2 significant figures. So what we can do is we can add a 0 here at the end. And our final answer, rounded to the appropriate number of significant figures, is 2.70 grams per milliliter. Practice problem number 3 is a little bit trickier. Problem number 3 states, what is the mass of the ethanol that exactly fills a 200.0 milliliter container? The density of ethanol is 0.789 grams per milliliter. The first thing we do, as always, is write our formula. D equals M over V. The second thing we do is we write our known and unknown values. D equals 0.789 grams per milliliter. Mass is what we're trying to find, so put a little question mark there. And our volume is 200.0 milliliters. Next, we plug in our values. So 0.789 grams per milliliter is equal to mass, we don't know, over volume, 200.0 milliliters. For the next step, we're going to have to cross multiply. We're going to multiply 200.0 milliliters times 0.789 grams per milliliter, and then mass times 1. What we're left with, since anything times 1 is just itself, we're left with M equals 0.789 grams per milliliter times 200.0 milliliters. Before we go any further, grams per milliliter times milliliters. Milliliters is on the bottom here, it's on the top here, so they cancel out, and we're left with the unit of grams, which is exactly what we want when we're calculating mass. So let's plug those numbers in. 0.789 times 200.0. That gives us mass equals 157.8 grams. But before we finish up this problem, we have to round to the appropriate number of significant figures. The density, 0.789, has 3 significant figures, and the volume, 200.0, has 4 significant figures. So we go with the lower number, significant figures, which is 3. So we're going to round this to 3 significant figures. 1, 2, 3. Put a box around the next number. Look in the window. Since 8 is 5 and above, that makes this 7 go up 1 to 8. So our final answer is mass equals 158 grams. And we always box off our final answer. Practice problem number 5 states, what volume of silver metal will have a mass of exactly 2,500 grams, and the density of silver is 10.5 grams per cubic centimeter? The first thing we do, as always, is write our formula. D equals M over V. And then our second step, we write our known and unknown values. The density of silver is 10.5 grams per cubic centimeter. The mass is 2,500.0 grams. And our volume is our unknown value. Next, we plug in our numbers. So 10.5 grams per cubic centimeter is equal to 2,500.0 grams over volume. Now we still have 2 more steps to go from here. We can put this 10.5 over 1 and we cross multiply. So we're left with 10.5 grams per cubic centimeter times V is equal to 2,500.0 grams times 1. Now we're almost done. We want to get this V by itself. So we have to divide both sides by 10.5 grams per cubic centimeter. 10.5 grams per cubic centimeter. In this case, the 10.5 grams per cubic centimeter and 10.5 grams per cubic centimeter cancels out. So we're left with V equals 2,500.0 grams divided by 10.5 grams per cubic centimeter. Grams and grams cancel out. We're left with the unit of cubic centimeters, which is exactly what we want for volume. So let's perform our mathematical operation. 2,500.0 grams divided by 10.5 grams per cubic centimeter is going to give you this very long number, 238.095238.1, and of course we're left with cubic centimeters. But we're not going to leave the answer like this. We're going to round to significant figures. If we look at our original values, 10.5 has 3 significant figures. 2,500.0 has 1, 2, 3, 4, 5 significant figures. So we're going to go with the least number, which is 3. 3 underlines, 1, 2, 3 underlines. Put a box around the 4th number. 0, which is below 5. So we round down. Our final answer is 238 cubic centimeters. And we box off our final answer. Practice problem number 7 states, a block of lead has dimensions of 4.50 centimeters by 5.20 centimeters by 6.00 centimeters. The block has a mass of 1,587 grams. From this information, calculate the density of lead. We start off as always by writing our formula. D equals M over V. And then we write down our known and unknown values. D equals, we don't know, that's what we're trying to find. The question asks us to calculate the density of lead. So that's our question mark. Our mass is 1,587 grams. And our volume they don't give us, but they do give us dimensions. They tell us a block of lead has dimensions of 4.50 centimeters by 5.20 centimeters by 6.00 centimeters. So from there we can find the volume. Let's take a look. So a rectangle, a block, looks something like this. It's 3-dimensional. And it gives us the dimensions of 4.50 centimeters by 5.20 centimeters by 6.00 centimeters. Remember, the volume of a rectangle is length times width times height. V equals length times width times height. So we just have to multiply these numbers together and we'll have the volume of this lead block. So V equals, we'll plug in 4.50 centimeters times 5.20 centimeters times 6.00 centimeters. We plug that in our calculator. So our volume 5.20 times 4.50 times 6.00. And that should give us, if you multiply these three numbers together, should give us 140.4. That's multiplying the numbers. We also have to multiply the units. Centimeters times centimeters times centimeters is cubic centimeters, or centimeters to the third power, how it's written. And it's cubic centimeters. So now we have all of our information. We have the mass and we have the volume. Now we find density. So we plug in. D we don't know, that's what we're trying to find, equals 1,587 grams over the volume, 140.4 cubic centimeters. We plug those numbers in our calculator. 1857 divided by 140.4. Hit enter. We write down every single number in our calculator. I get 11.3034.188, and of course we have the units of grams per cubic centimeter. The very last thing we need to do is round to the appropriate number of significant figures. For that, we look at the original numbers only. So 4.50, that's three significant figures. 5.20, three significant figures. 6.00, three significant figures. And 1,587 will have four significant figures. So out of all the numbers, the least number of significant figures is 3 by the three measurements for volume. So we round to three significant figures, draw three lines, 1, 2, 3. Go to the fourth number, put a box around it. Look in the window, we see 0. Obviously that's lower than 5, so all these numbers drop out, which means our final answer, density equals 11.3 grams per cubic centimeter. And of course, we box off our final answer. And finally, we have practice problem number 8. Problem number 8 states, 28.5 grams of iron shot is added to a graduated cylinder containing 45.50 milliliters of water. The water level rises to the 49.10 milliliter mark. From this information, calculate the density of iron. So we start off this problem as always. We write our formula. D equals M over V, where density equals mass over volume. Then we write our known and unknown values. For density, we do not know density. The problem asks us to calculate the density of iron. So that will be our question mark, our unknown. Mass we do know. We have 28.5 grams of iron. But for the volume, once again, we have to do something to figure out the actual volume of the iron. So now we have a graduated cylinder. Pretend this is just a graduated cylinder. We started off, I'm just going to draw 45, 46, 47, 48, 49, and 50. So we started off with 45.50 milliliters of water. So that's 45.50 milliliters of water. That's when we started. Then we threw the object in this case, the iron shot went in. So I'll put Fe for iron. That went in. Then the water level rose to 49.1, so something about right about here. So the difference from here to here will be the volume of the iron shot. So the formula to find this, very simply, to find the difference, it's the final volume, so V final, minus the initial volume, V initial. The final volume, what we ended up with, was the 49.10 milliliters, minus the initial, what we started off with, was 45.50 milliliters. So when we subtract those two numbers, that's when we get the actual volume of just the iron shot. So 49.10 minus 45.50. The calculator gives us 3.6, but we're going to put a 0 here at the end. Remember, when you're doing significant figures with addition or subtraction, it goes by the least number of decimal places. So 49.10 has 2 decimal places, and 45.50 also has 2 decimal places. So we're just going to make sure that our volume has 2 decimal places as well. From here, just a regular density problem. We plug in the numbers. We don't know D. D equals 28.5 grams divided by 3.60 milliliters. We punch those numbers in the calculator, 28.5 divided by 3.60, and we get a very long number that comes out of the calculator. Our density is going to equal 7.916666667. Our units are grams per milliliter. And then our final step is to determine the number of significant figures. 28.5, 3 significant figures. 45.50 is 4 significant figures. And 49.10 is also 4 significant figures. We're dividing, so the least number of significant figures is 3. Underline the first 3 numbers that are significant. Put a box around the 4th number in this case. We look in the window, we see a 6, which is higher than 5. 5 and above, we round up. So that 1 becomes a 2. So our final answer, density equals 7.92 grams per milliliter. And we box off our final answer. Thank you for joining Mr. Alvarez's virtual chemistry classroom. Today we learned about density. The formula for density is density equals mass over volume. But we can also rearrange that equation to solve for mass. Mass equals density times volume, or solve for volume. Volume equals mass divided by density. We also saw different ways in which we can find the volume. The volume of a rectangle, we would use V equals length times width times height, or we could use the water displacement method, where we have a set amount of volume of water in a graduated cylinder. We drop the object in, and then the volume of the water in the graduated cylinder rises. The difference between the final and the initial water level readings on the graduated cylinder would be the volume of that object. Thank you again for joining us. I hope you learned something today. Please join us again soon.